Okay, so here we go. We're starting the trigonometry part. I'm going to start at number 16 here, and we'll see how far I make it. Okay, so find the exact value of the trigonometric function indicated no decimals. That means we want fractions. We need to remember our friend SOHCAHTOA. Again, that might be something for your note card, or your pink sheet, I should say. So here's theta, and I need to find tangent. Tangent is opposite over adjacent. So opposite theta would be 5. Adjacent would be 12, because my only two options left are 12 and 13. One of those is the hypotenuse. The other one would be my adjacent. Therefore, my answer there is D. All right, find sine of theta if tangent of theta is radical 13 over 6. Now, I know that tangent is opposite over adjacent. So if I just draw a triangle, a really bad triangle, hang on, let me draw a better one. Draw a triangle. So let's say here it is. We're going to call this theta right here. They're telling me the opposite side is radical 13 and the adjacent side is 6. Now if I want sine, I need opposite and I need hypotenuse. So I know that the opposite is radical 13. How can I find the hypotenuse? Pythagorean theorem. 6 squared plus radical 13 squared is equal to c squared. So 36 plus 13 equals c squared. 36 plus 13 is 49. So c is equal to 9. C is equal to 7. Been doing too many of these. So radical 13 over 7 would be my sine value, and that's option D. Okay, same kind of problem, except this time they give me sine. So they're giving me opposite and hypotenuse. So I'm going to set up my triangle. Again, here's my right angle. I'm going to call that one theta. Doesn't matter which one you call theta. Opposite is radical 11. Hypotenuse is 6. If I want tangent, I need opposite and adjacent. So it's going to be radical 11 over something. So I'm going to use Pythagorean theorem again. Radical 11 squared plus b squared equals 6 squared. That's 11 plus b squared equals 36. Subtract my 11. B squared equals 25. Therefore, b equals 5. So it's radical 11 over 5. And that would be option C. All right, find the measure of the indicated angle to the nearest degree. Well, here's the angle that I'm looking for, and they happen to give me adjacent and hypotenuse. What uses adjacent and hypotenuse? That would be cosine. So I'm going to say cosine of theta is equal to adjacent over hypotenuse. Now, whenever you're looking for an angle measure, that's when you're going to use the shift cosine thing on your calculator that gives you the -1, and that's how you're going to get the degree measure. So over here I'm going to hit second or shift cosine. See, I got the -1 thing there, and then I'm going to plug in 37 divided by 57, and the result is the angle. That's 49.5. What do they say? Find it to the nearest degree. 49.5, we'll go ahead and call that 50 degrees. There's my answer right there, option D. Okay. All right. Find the measure of the side. Again, still going to use SOHCAHTOA here. Okay. Anytime you have a right triangle, you can use Pythagorean theorem. You can use SOHCAHTOA. Can't necessarily do that over here because it's not necessarily a right triangle, unless you happen to find out that angle A is 90 degrees, which I don't think it is there. So here's my angle. They give me adjacent, and they give me hypotenuse. That's going to be cosine. So I'm going to say cosine of 34 degrees is equal to adjacent over hypotenuse. How am I going to solve that? I'm going to multiply both sides by x. That gives me x cosine 34 equals 6. Divide both sides by cosine 34. And x equals, on my calculator, 6 divided by cosine 34, 7.23 If I call that 7.2, my answer is B. Okay. All right, let's see. What do I know here? I need to find AB. That is this length right here. So I'm going to call that X. Now, I have an angle and I have the opposite side. I have an angle, I don't have the opposite side, but I have a side and I can find this angle, can't I? Since I know the other two. So I'm going to go ahead and do that so that I can use the law of sines. You might want to remember the law of sines. That was sine A over A is equal to sine B over B is equal to sine C over C. And that's what we can use when we don't have a right triangle. You can also use law of cosines, but I'm going to use law of sines here. So let's see. How do I find that other angle? I'm going to take 180. I'm going to subtract the 27-degree angle and subtract the 115-degree angle, and that leaves me with A as 38 degrees. Now, I can put sine of 115 over X equal to sine of 38 degrees over 19. How am I going to solve that? Cross multiply. 19 times the sine of 115 equals X times the sine of 38. I'm running out of paper. 38. So if you're listening to this on mute, you're not going to know what number that is. Okay, to get X by itself, I'm going to divide by sine 38. Divide by sine 38. And so I have X by itself. I just got to plug all that into my calculator. So 19, sorry about the glare, times the sine of 115 is equal to that, divided by the sine of 38 degrees, and I get 27.96. What's closest to 27.96? That would be option A. That's my answer there. All right, here we go. Number 22. I don't think I can use law of sines here because I only know one angle, and that doesn't help me. I can't find other ones easily. So I'm going to have to use law of cosines. Here's law of cosines. A squared equals B squared plus C squared minus 2 BC cosine big A. The biggest thing about this one is whatever side you're trying to find, that's the cosine value there. So little a goes with big A, little b goes with big B, little c goes with big C. These two things in here are whatever the other two letters are. So I could do b squared and cosine b, and it would be c and a that are made up in there. Again, that's a formula you probably want to put on your sheet. So I'm going to call this little a. That's the side I'm trying to find. So a squared is equal to little b plus little c squared minus 2 times 21 times 22 times cosine of 133. And it looks like I can just plug that straight into my calculator. So let's see. 21 squared plus 22 squared minus 2 parentheses 21 parentheses 22 cosine 133, and I get 1555.166 blah blah blah. I need to square root it though. So I'm going to second square root the answer, and that gives me 39.4. That would be option A. So that's our easy way of using the law of cosines. Again, put it on your note card. All right, find the measure of the indicated degree. Let's see. I think I can use law of sines here because I'm looking for an angle. So I want to use law of sines. So I'm going to call that H. So I can do sine of 123 degrees over 43, those are my matching ones, is equal to sine of H over 15. So let's see, if I cross multiply, I get sine 43 sine H is equal to 15 sine 123. I'm going to divide by 43. So I have sine of h by itself. And let's see what I get. 15 sine 123 is that, divided by 43 is 0.29255, blah, blah, blah. Now, I'm going to have to do inverse sine, because I'm looking for an angle of that 0.29, blah, blah, blah. So watch what I'm going to do. I'm going to hit second sine, there's my inverse, and second, my answer button down at the bottom, so it'll do the inverse sine of the previous answer. That way I don't have to retype everything in. 17.0, so I'm going to say that's about 17 degrees. That's option A. Okay. All right, find the area of each triangle to the nearest tenth. Another formula. Area. If you write these formulas down and you can access them easily on the final, you should be good to go with a lot of this stuff. It's 1/2 A times C times sine of B. There's little a, there's little c, so it's actually 1/2 of a side and a side times the sine of the included angle. So if I had this side and this side, I would need this included angle as well. So there's different forms it can take, and you may want to write all the forms, doesn't matter. But I'm just going to plug in 1/2. Little a is 12. Little c is 12. I have a nice isosceles triangle there, don't I? Times the sine of 36 degrees. So 1/2 times 12 times 12 times the sine of 36, 42.3, right there. Option C. Okay. All right, convert the degree measure into radians. Whenever you're going from degrees to radians, you multiply by 180 on the bottom, pi on the top. Sorry, I said that backwards. Multiply by pi over 180. So negative 255. I'm going to multiply that by pi over 180. So that's negative 255 over 1. That gives me negative 255 pi over 180. And I'm going to go to my calculator to reduce that. Negative 255 over 180. Get my improper fraction. Negative 17 pi over 12. And that's option D. Negative 140, same thing, multiply by pi over 180. That gives me negative 140 pi over 180. I'm going to reduce negative 140 over 180, negative 7 pi over 9, and that's B. All right, opposite, converting radians into degrees. Whenever you're going from radians to degrees, you multiply by the reciprocal of that, 180 over pi. I wrote that wrong, radians to degrees. So I'm going to multiply by 180 over pi. Now, 31 times 180 is 5580. Notice there's a pi on the top. On the bottom, 6 times pi is 6 pi. The pi's will cancel. I just need to know what 5580 divided by 6 is, and it's 930 degrees. That's option A. Same story over here. Multiply by 180 over pi. Let's see, 53 times 180 is 9540. There's a pi. On the bottom, I have 36 pi. The pi's cancel, so I just need to know what 9540 divided by 36 is, and it's 265. And that's D on that problem. Alrighty, find the measure of each angle. Back to our angles in standard position. So let's see. I have an angle that's starting off in our initial side right here, but it's going down. So whichever it is, I know it's going to be negative, which all of my options are negative, so that's good. If I go negative and I make it all the way back to that initial side, I have at least negative 360, right? Going another quadrant, this would be another 90 degrees. Then I have another bunch right there. Now, I don't know how much that is, but they tell me that's 45 degrees. So if this whole quadrant right here is 90 degrees and this part's 45, guess what this has to be? Also 45 degrees. So putting that all together, I went 360, I went another 90, and another 45. So 360, another 90, and another 45 mean I'm at 495 degrees, and we know that's negative. Okay. This time we have a positive one. It looks like we have radians. Now, you can either speak in fractions, or you can go ahead and translate this by changing this to degrees right here, same way we did those, but then you'll have to translate these to degrees also to make sure you're getting the right answer. So if I remember from my unit circle, way back here, 1 quadrant is pi over 2, it's 1/2 pi, which means that if I'm talking in 12ths, this whole quadrant would be 6 pi over 12 because that's 1/2. Each quadrant represents a half of a pi. So if this is 5 pi over 12, this is 1 pi over 12 to get that 6 pi over 12 total. I'm not sure I'm going to need that, but we'll see. So this one's going in a positive direction, and it goes 1 full rotation. In radians, a full rotation is 2 pi. 1 more quadrant means I have another pi over 2, or 1/2 pi, just like I was explaining over here. And then we have an additional 5/12 pi. So I need to add 2 plus 1/2 plus 5/12. 2 plus 1/2 plus 5/12. That's a lot of common denominators I got to get. Gives me 35 pi over 12. Again, feel free to transfer that to degrees if you need to, if that makes it easier for you. So here we go. Find the reference angle. Now remember, the reference angle is the angle that is made with whatever angle you're talking about and the x-axis. Always the x-axis, never y. So if I look at my unit circle on my pink sheet, 120 degrees is right here. 120 degrees, not to the y-axis, but to the x-axis. I have to figure that. Well, the distance between 120 degrees and 180 degrees is 60 degrees. So my answer would be A right there. 32, 310 degrees, also on my unit circle. So let's see. Nope, not quite on my unit circle, but I know it would be in here, right? So if I was at 310, to get to 360, where my x-axis is, I would have to travel another 50 degrees. All right, negative 4 pi over 3. Again, you can convert to degrees if you need to. Negative means I'm going this way. So those of you in my class should be familiar with the fractions. So this is negative 1/3, negative 2/3, negative 3/3, and this would be negative 4/3. So if this was negative 3/3 and this is negative 4/3, we are 1/3 away from our x-axis. That would be pi over 3. And 13 pi over 4, is that on my, let's see, we have 1 pi over 4, 2, 3, 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. This would be 8, so I'm going to keep going. 9, 10 pi over 4, 11 pi over 4, 12 pi over 4, 13 pi over 4. How far is it from the x-axis? Just pi over 4. Something that is nice about your reference angles is when you have a 3 on the denominator, look, you have a 3 on the denominator of your reference angle. When you have a 4 on the denominator, you have a 4 on your denominator of your reference angle. We did a little worksheet that had patterns on there, so if you can remember that, that's great also. All right, coterminal to 23 pi over 12, and then there's a list here. So what I'm going to do is I am going to add 2 pi over and over again to this and see what I get on here. Now I'm also going to have to subtract 2 pi. Why do I add and subtract 2 pi? Because that's 1 full revolution. So I'm going to take 23 over 12 and I'm going to add 2 to it. That gives me 47 over 12, so we have a coterminal right there. If I add another 2 and change it to my improper fraction, 71 over 12, that's not on my list, so it doesn't look like 11 over 12 is not going to be there. Doesn't look like any of those. So if I subtract 2, if I go back to my original one, 23 over 12, and I subtract 2 this time, negative 1/12. If I subtract another 2, I get negative 25/12. Those two happen to be the same, so they're wrong. So I need whichever answer has these 3 on it, and it looks like it's option D. Okay, same deal here, 240. I'm going to add 360 over and over again, and I'm going to subtract 360 over and over again. 240 plus 360 is 600, plus another 360, 960, 780 it skipped, 420 it skipped. 240 is coterminal to itself. Now let's go back to 240 since all these are smaller, and let's subtract 360. Skipped over 60, goes to negative 120. Subtracting another 360, I get down to negative 480. It skipped over 300. So I need whichever one has those 4. It looks like option B. Let's see, 600, negative 120, 960, negative 480, and 240. Yep, that's option B for us. Okay. All right, use a unit circle to find the exact value of each trigonometric function. For these ones, remember, when you are looking for cosine of theta, you are using the x value of the coordinates. If you are looking for sine of theta, that's the y value of the coordinates. If you are looking for the tangent value, that is equal to, so tangent would be sine theta over cosine theta, or you can also think about that as y over x just by substituting those values. So cosine of negative 120. I'm going to find negative 120 on my unit circle, and then I'm going to use the x value there. So negative 90, negative 120 would be right here. The x value there is negative 1/2. Therefore, the cosine of negative 120 is negative 1/2. Moving on to the next page. The tangent of 11 pi over 2. So let's see. 11 pi over 2. Let's see, 1, 2, 3, 4 pi over 2, 5, 6, 7, 8 pi over 2, 9, 10, 11 pi over 2. That angle is coterminal with 3 pi over 2 or 270. Sorry, you can't see that. So tangent would be sine over cosine, or y over x, and 1 over 0 is undefined. Cosecant, this is something else you might want to put on your chart. That's sine and cosecant are the reciprocals of each other. That cosine and secant are the reciprocals of each other. And that tangent and cotangent are the reciprocals of each other. So I'm looking for cosecant, which is the reciprocal of sine. So I'm going to start off by finding just the sine, and then I will reciprocate it. So let's see, 3 pi over 4, I think that's one of the values on here. Here it is. Sine is the y value, so that's radical 2 over 2, and it's positive in this quadrant, so that's good. Now if I flip that, I get 2 over radical 2. Got to get that radical off the denominator. So I'm going to multiply by radical 2 over radical 2. That gets me 2 radical 2 over 2, which leaves me with just radical 2, which is A. Okay. All right, sine of negative 225 degrees. So let's see, negative 225 degrees would be right up here, coterminal with 135 degrees. And the sine value there is radical 2 over 2, which is option A. Secant of theta, when we have negative 1050. So what I need to do is I need to find what it's coterminal with it, and find the secant of it. Now, secant is the opposite of cosine, so I'm actually going to find the cosine, and then I will flip it upside down. So, 360 and another 360 gets me to 720, plus another 90. Let me get my calculator here. 720 plus 90, plus another quadrant would be another 90, plus another quadrant would be another 90, which makes this 990, or negative 990 I should say, and this is negative 1050. So what's that distance? 1050 minus 990 is 60 degrees. which means this is 30 degrees. We are coterminal with a 30-degree angle. So looking at 30 degrees, the cosine value is equal to radical 3 over 2. So what I need to do is flip that upside down. That would be 2 over radical 3, multiply by rad 3 over rad 3. And that gives me 2 rad 3 over 3. That's my secant value for negative 1050. Okay. All right. Cotangent. So again, I have a 5 pi over 4. That means it's going to be coterminal with whatever is pi over 4 in that quadrant. Now, cotangent in that quadrant is going to be the reciprocal of tangent. It's actually always the reciprocal of tangent. But negative over negative is going to make it positive in this quadrant. So my answer needs to be positive. So I doubt it's going to be one of those guys. So I'm going to do tangent is sine over cosine. Cotangent is the reciprocal, cosine over sine. So I'm going to put the x value, which is negative radical 2 over 2, over the y value, which is negative radical 2 over 2. Now, if you notice, that's the same thing over itself, and anything over itself is 1. Okay, and I think this will be the last one for this set, because after this we go into the graphing of trig, which is just as much fun as this is. I know you're enjoying this. Use the given point on the terminal side of angle theta, so they're calling this angle theta, to find the value of the secant of theta. So this is the one where we need to draw a triangle. And I'm actually going to draw that triangle like this. Here's my theta. Theta is always at the origin. I always get questions about that. Where do I put theta? Here or here? It's always got to be at the origin. And this is 3, negative 6. So I'm going to call this 3 and this 6. Now technically this is negative, but we can't talk about a length being negative. What I am going to think about is what is positive in each quadrant. Remember we did that all students take calculus. Everything is positive here. Over here it would be sine and therefore cosecant. Over here is what's positive. Tangent and cotangent are positive in the 3rd quadrant, and cosine and secant are positive in the 4th quadrant. So if cosine and secant are positive in the 4th quadrant, I know that my answer is going to be positive. I can drop off A and D as possibilities. So I need to find cosine and flip it. So I need adjacent, which is 3, and I need the hypotenuse. How am I going to find the hypotenuse? Pythagorean theorem. 3 squared plus 6 squared equals c squared. 9 plus 36 equals 45. So 45 is equal to c squared. Therefore, radical 45 is equal to c. Was I right ahead of myself here? So 3 over radical 45. I can simplify that if I want to, or I can just go ahead and get it off the denominator first. I'm going to get it off the denominator. Multiplying by radical 45 over radical 45. That gets me 3 radical 45 over 45. Now, I can draw a tree for that 45. Breaks down into 9 and 5. 3 and 3, I can take a 3 out. Now, if I take a 3 out and there's already a 3, I have 3 times 3 outside and a 5 left inside. And on the bottom, I have 45. So that's 9 radical 5 over 45. And the 9 and the 45 will reduce to 1 and 5, I believe. So I end up with option B as my answer, I think. And now I'm going to correct myself because what I just found at the radical 5 over 5 was the cosine, and I need the secant, so I actually have to flip it. Forgot that part. Now, it's actually easier if I flip it here because then I don't have to go through all this simplifying. If I were to flip it there, life gets simpler, but I'm going to go ahead and flip it. Now that I've simplified it, that gives me 5 over rad 5. And if I multiply by rad 5 over rad 5, I get 5 rad 5 over 5, which is just rad 5. So notice the opposite one was a possibility. That very well could happen on the test if the opposite one is a possibility for your answers. So, glad I checked myself on that one. All right, more trig to come. Happy studying.